All right, let's go ahead and start with some introductions. So my name is Chuck Ridgway. I'm the Automation Technology Manager at Horner. And joining me, we have our Product Manager, Casey Gardner. How are we doing today, Casey?
If I can unmute. I'm good. How's it going, Chuck?
Going well. Yeah, gotta love it when the technology guys, including you and me, have tech problems. Now let's see how our marketing person does with the tech. How's it going, Marcy?
It's going great, Chuck.
Impressive how she found the mute button so much quicker than Casey or I.
I practiced yesterday.
There you go. Exactly. Yesterday we had our Tuesday YouTube, and Marcy didn't realize her mic was live during the opening for YouTube, but that's okay. She didn't embarrass herself for anything like that. All right. Well, thanks for joining us. We're going to present the material for you. Now we've got all the information on the launch. And then at the end, we're going to be answering your questions. Specifically, Casey Gardner is going to be answering any questions that you might have regarding our new IO Link products. Let's go ahead and get started. Here's what we're going to cover today. We're going to give you an overview of what we're releasing from an IO Link standpoint and a little bit of background as to why we've decided to release an IO Link set of products. Why IO Link in general? What are some of the strengths of IO Link? Why is it becoming very popular in the automation market? We're going to give you the nuts and bolts of the specific products that we're releasing initially, along with some accessories, and give you an opportunity to kind of see what those parts look like. And we've got a couple videos, one of which is a demonstration of IO Link in action with the OCS. And of course, we'll talk about the rollout schedule as well, so you know when you can order and when you can start receiving our new IO Link products. Overview and background. Why are we adding IO Link to OCS as a possible solution? Well, first of all, we have been receiving requests for IO Link for some time now. So at least 5 years by my recollection. And frankly, it has been on our product roadmap since 2019. So we made a decision quite a while ago that we were going to do IO Link Masters specifically, connected either to OCS or to one of our IO platforms. And we just have not had an opportunity to spend a lot of time on that development because we've been focusing on some other key products. Last year, we released XL Prime, which is a newer, faster, updated version of our popular XL series. We have released OCS IO, which is our latest remote and expansion IO family. We've got a lot still going on with OCS IO you're going to be excited about in the future. Later this year, we've got a new OCS product line coming called Canvas that you'll learn all about in a few months. And so we've been so busy on our core products that it just made sense to partner with another company on the IO Link products themselves and to get those released sooner rather than later. So we are specifically launching 2 new IO Link Master products that are compatible with pretty much any OCS, certainly any modern OCS. So when I say modern OCS, I'm talking about micro OCS. I'm talking about our traditional XL family, from the XLE and XLT all the way up, XL4s, XL7s, etc., the new XL Primes, and then as Canvas is released later on in the year, it'll also support the IO Link as well. Now, we did not design and manufacture these products. We are working with Banner Engineering on them. So effectively, they have designed them and are manufacturing them, and then we're selling them as Horner part numbers through our distribution channel. So the normal places that you go to buy your Horner products, you'll be able to get these IO Link Master products. And what we're focusing our efforts on, in addition, of course, to the nuts and bolts of getting these products in stock and documented and all those sorts of things, is we're really focusing our efforts on ease of use and OCS integration. So you're going to see lots of example programs, lots of documentation, some special user-defined function blocks, and those sorts of things, just to make your efforts as application engineers easier when you want to add one of these products in your next OCS application. So initially, we've got this pair of IO Link Master products. They're both the IP67 rated products. We have a 2-channel shown in the upper right there, and then a 4-channel shown in the lower right. You'll be able to use these products with any Horner OCS controller. Again, any modern Horner OCS controller. So there aren't any specific requirements. In terms of configuration of your IO Link devices and of any non-standard master type configuration changes that you would make, you'll be using the Banner software for that. So we considered briefly doing a Horner version of the software, but it just made more sense as Banner is making improvements, on a regular basis, it just made more sense for our customers to be able to take advantage of the latest version of the Banner software at any given time. So of course, we'll be posting the Banner software on our website, on the IO Link web pages that you'll be able to find on our website, but we are not brand labeling or anything like that, the software that'll be used for IO Link device configuration. And again, we're focusing on runtime integration and ease of use. Let's take a first look at these IO Link master products. All right, let's take a physical look at these IO Link masters here. I've got the 2-channel and I've got the 4-channel. Now for reference, here's the size of my hand. All right, and as you can see, these guys are pretty compact. So with the 2-channel, we've got IO Link on the left, top and bottom. So that's 2 channels there, with the RTU Modbus and power connections there on the right. All connections are with M12 connectors, M12 by 5. All right, and then we've got the 4-channel master. Again, this time on the left, we have our connection via Modbus and power input. And on the bottom, we have our 4 IO Link channels. Plenty of LEDs. Of course, they're not lit up right now, but plenty of LEDs for diagnostics. A couple of nice holes here for permanent mounting. Just a really terrific product. Okay, so that'll give you an idea of what we're talking about physically in terms of physical size. Now, as you can see on the pictures here, the connection to the OCS on these particular pictures is off to the right, but these master products can be flipped around horizontally as well. So if it's more convenient for your machine, you can have the connection on the other side. You just need to flip it around. They're basically symmetrical. Now let's spend a few minutes talking about IO Link itself. Some of you are probably extremely familiar with IO Link. You've probably used it on other projects. Others may be not as familiar. So let's talk a little bit about what is IO Link. So one thing that I know was a misconception for me before I started learning more about IO Link is originally I was thinking, okay, IO Link is another field bus, but it is not. It's definitely not a field bus. It's sometimes used alongside a field bus. Matter of fact, it most often is, but it itself is not a field bus. It features point-to-point type communications, not multi-drop type communications or, Ethernet type communications like you'll find with field buses and with industrial Ethernet. So really what IO Link is designed to do is it really is designed to kind of modernize and improve the integration of sensors and actuators. It's not just for sensors in automation systems. So, our traditional approach, which we still use today highly extensively, of course, which is we have standard inputs and outputs that are either analog or digital. We use typically 24-volt type signals in most machine control applications for our digital IO. We use either 4 to 20 milliamp or 0 to 10 volt signals along with temperature sensors and those sorts of things for our analog IO. And that is our primary way of getting IO into a PLC or an OCS today. What IO Link does is it really looks to kind of modernize that approach, offering some capabilities that you don't find with traditional IO. The other thing about IO Link is, and I mentioned the fact that we had first been requested to support it several years ago now, but at this point in 2023, there are IO products literally from hundreds of automation suppliers. So let's start talking about the nuts and the bolts a little bit here. So when you're talking about traditional sensors and actuators, inputs and outputs wired as, your typical 24 volt in or 24 volt out, one way to get those products in a lot of cases is to order them with M12 connectors on them, especially if you're looking to install them right out in the machine environment and not necessarily behind a control enclosure. It's pretty common to order them with an M12 style sealed connector. And in that sort of scenario, there's different pinouts involved, but in general, the most consistent pinout would be where you have 2 pins on that M12 connector, which are used to supply power to the sensor or the actuator, and then 2 more pins that can be used either as an input connection, an output connection, or some combination of both if it's an in-output device. Okay, so that's your traditional sensor. You also will find analog sensors with this sort of connection as well. So instead of a digital type connection on pins 2 or 4, you might then have your analog style connection. IO Link does things a little bit differently. It's definitely geared around, typically at least, the M12 type connection. That's the most common way that you'll find it, at least physically. But what you'll find that's a little bit different, you still have 2 pins for power, typically 24 volts, although it's wide range, or at least somewhat wide range. You still have an IO type connection, a traditional IO type connection on pin 2, but on pin 4, what you've got is called the CQ communications pin. And what that is an actual digital communications port. So it's not just on off, but it's on off at a rapid rate so that you've got bidirectional communications that can occur between an IO Link master on one side and an IO Link device on the other side of that connection. So that's one of the physical differences you'll find with IO Link, is that CQ type digital communications type connection. Now let's talk about some of the advantages that IO Link does have and some of the reasons why some folks, at least for some of their sensors, like to utilize it. Let's start with the advantage from a data standpoint. Okay, so let's talk about a distance sensor. Like I've got a laser sensor shown there on the screen. With our traditional approach with a distance sensor, we're going to have either a 0 to 10 volt or a 4 to 20 milliamp output from that sensor. We're going to wire it into an analog input on a PLC or an OCS in our case. And effectively, one of the limitations in that connection is going to be the resolution of the analog conversion from analog to digital that's done in the PLC or the OCS. Another limitation, of course, is going to be the stability of that signal, the noise immunity of that signal. So there's going to be several potential scenarios where you can lose some resolution, lose some accuracy based on how well that analog transmission occurs between the sensor and the PLC or the OCS in our case. Now, for 95% of the applications, it's really not an issue. However, one of the advantages of IO Link is that the communications between a distance sensor, for example, and a PLC or an OCS is digital instead, right? So you're actually getting the actual value that the sensor is attempting to send. Instead of the sensor converting it from digital to analog and then vice versa in the PLC, that digital signal, or digital value, if you will, or decimal value, if you will, is transmitted through a communications interface. So that can be a big advantage, especially if you're talking about a signal that has a lot of resolution and if you can really take advantage of that resolution. Of course, you can't take advantage of the resolution in every case. Another thing that you can get through that communications interface is you might be able to get more than just the basic information. So for instance, it might be a distance sensor like we're talking about, but maybe it can also transmit temperature information or some other data that the sensor is actually kind of sensing as part of its construction, but that it normally wouldn't pass on to a PLC or to an OCS, because it's got one output, analog in most cases, for that sort of sensor, and it's not going to send anything other than the primary distance for a distance sensor. So that's an advantage. Sometimes you can get some extra data in addition to, of course, getting the data you're primarily after in a more exact form. Some of you are probably thinking, well, wait a minute, field buses have been doing this for 30 years, right? Why not just take your sensor and connect it directly to Ethernet IP or to Profinet, or maybe even one of the older field buses like Profibus or something? And certainly you could do that. There's no question about that. Again, field buses have been communicating those sorts of digital data for years. However, one advantage that IO Link does have that's nice is it's actually a lot more inexpensive to add IO Link to a sensor than it is to add a field bus, whether that's Ethernet based or maybe CAN based or something, or RS-45 based field bus. So yes, you could do it with a field bus, but more than likely it's going to cost a lot more money. Now, if you've got an extremely sophisticated sensor, maybe a $2,000 or $3,000 sensor, it may not cost a whole lot more for them to put a field bus interface on it as it would an IO Link interface. But for a less sophisticated sensor, for sure, IO Link is just a marginally additional cost. Let's talk about another advantage to IO Link, and that is the fact that you can back up the configuration of the sensor right in the IO Link master if you set up the system that way. So let's take an example where, let's say we've got a highly sophisticated sensor, and it's taking us maybe a matter of hours or even maybe a couple of days of experimentation to figure out the optimum setup for the sensor. The sensor is a key element in the production of our machine, so it's worth putting all that time into it and getting it set up just the way we want it. And then after we've put in all that time, the sensor is exactly the way we want it, and the machine is running like a dream. Now, what happens a few months down the road, or maybe even a few years down the road, when for some reason that sensor needs to be replaced? Well, if the original engineer on the project didn't write down all the parameters, if he didn't back up the parameter settings to some sort of software, it's very possible you'll need to completely repeat that whole process again to get your sensor back where you want it and your machine back up and running again. With IO Link, you have the capability, if you set it up that way, to have the master actually backing up the configuration of your sensor in its memory, so that in the future, again, if you set it up this way, you can add a fresh sensor from the factory, and then after you connect it, it can receive its configuration from the master, and you can be back up and running in no time. Certainly much faster than having to repeat the whole startup sequence again. Now, another advantage of IO Link that a lot of people don't really think about is the fact that a lot of IO Link sensors are highly configurable in the field. So traditionally, when we're ordering sensors for our machines, very often we're used to seeing a lot of different options available from sensor manufacturers. They often have what we would call a boxcar type part numbering scheme with all kinds of different options available to be ordered. Sometimes you need a couple of those options, maybe normally closed instead of normally open, maybe some other parameter that is different than maybe the most common sensor. With IO Link, as much as possible, they try and allow those parameters to be set in the field. So now, instead of ordering a sensor that, for all intents and purposes, is build to order because of some special things that you need, it's very possible you'll be able to order an off-the-shelf IO Link sensor and then just make the changes that you need in the configuration via software. So now you potentially could be ordering a sensor from stock, or at least with a very short lead time, as opposed to a really long lead time build to order type sensor. So that's another advantage a lot of people don't really think about. Now let's get down to the nuts and bolts of the specific part numbers and those sorts of things on the products that we're going to be releasing. So let's start with our 2-channel IO Link master. So the part number is there on the screen, as you can see, HE-IO Link 2 CHRTU, and it's very cost effective. One of the reasons we chose the IO Link masters that we did is because we felt very confident we could get excellent performance out of them, but at a very good cost. So a lot of our systems are used on lower cost type machines in some cases, especially with our micro OCS series. And we wanted to make sure that our IO Link solution was affordable, but still performed well. So our 2-channel, as you can see, has a pretty competitive list price. Now, from a connection between the OCS and the IO Link master standpoint, that connects over RS-45 Modbus MJ2. I know what some of you are thinking, oh no, Modbus is slow. Well, wait till you'll see the demonstration. You'll see that it's not a slow connection at all. We're able to have a very snappy configuration and snappy performance with these IO Link masters. Now, from a configuration standpoint, if you need to change anything from the defaults in the master itself or need to configure the sensors themselves, you can use the standard Banner IO Link config software to do that. Whether you download that from the Horner website or whether maybe you download it from the Banner website, you're going to be getting the same software in that case. Now, in terms of the way that you program your OCS to interface with that IO Link master, we're in the process of working on some ladder logic examples as well as some user-defined function blocks for those of you who use variable-based languages like variable-based advanced ladder or the IEC languages. We'll have some UDFBs that you can take advantage of for interfacing with the IO Link masters. So those are things that we're working on that we'll provide over the upcoming next few weeks. Okay, and then in addition to the 2-channel master, of course, we've got the 4-channel master. Its part number is almost identical, but with a 4 instead of a 2. Imagine that. Same scenario exactly in terms of how it's configured and the way that you interface with it from a programming standpoint in a Horner OCS. Okay, now there's some other accessories that we need to tell you about that you're going to need if you're going to integrate OCS with one of our IO Link masters. First of all, you're going to need an IO Link configuration kit. So you might be thinking, why would I need one of those? Well, if you're going to be making any configuration changes to the master, or if you're going to be configuring any IO Link devices through the master, then you're going to need to have a way to interface your laptop or your computer that you're using for development, typically over USB, to the IO Link master. So that's what that configuration kit is all about. It's got a USB cable or end to plug into your laptop or your computer. It has an M12 type connector to plug into the IO Link master. And then, of course, it's got a plug-in wall wart power supply to make sure everything's powered up while you're doing the configuration of the system. And of course, you're going to use that IO Link software from Banner, but you can get it from the Horner website. Another accessory you're probably going to want to take a look at from Horner is a OCS MJ2 to IO Link cable. So we've got a special cable that we'll be offering. We don't have the part number for you or the pricing, but it's effectively, you can think of it like a Y cable. So at the bottom leg of the Y, you have the M12 connector that connects to the master, the IO Link master. And then on the other end of the Y, you've got an RJ45 connector for plugging into the OCS, and you've got a pair of flying leads for putting power for 24 volts to run not only the IO Link master, but also any IO Link devices plugged into that master. And then if you're going to be using kind of standard M12 type cabling on your machine, then you might also want to use a bulkhead connector, which effectively is going to take that Y cable, the M12 end of that Y cable, and bring it nice and neatly to the outside of your control enclosure where you can maintain an IP67 type environment if that's important in your application. Now, there's another IO Link product that we're strongly taking a look at. We'll probably be offering this shortly after launch, and that is an IO Link hub. So what is an IO Link hub? Well, the IO Link hub we're taking a look at is an 8-port model. And what it does is it allows standard sensors and actuators to be connected to a single hub, this one with 8 ports. And then all of those sensors and actuators are aggregated as one IO Link device. And then they require one IO Link connection to the IO Link master. So this is a way that you can take advantage of IO Link, but also still use standard sensors. So of course, you don't get some of the advantages of configuration storage and digital communications of data necessarily, but you do get to take advantage of IO Link distribution. When you're using an IO Link type system, even though it's technically not a field bus, you're still going to need to use a collection of M12 cord sets and accessories. Depending on how sophisticated your IO Link setup is, you may only need cord sets, but if it's more sophisticated, you might need T's and terminators and those sorts of things. Now, I'm sure plenty of you watching out there are already buying these sorts of products from a variety of different automation suppliers at your local Horner distributor. And of course, those products will work just fine with our IO Link masters, but we will likely offer some of these accessories on our website just for convenience as just another place you can source these products. Next, we're going to give you a demonstration of an OCS with IO Link in action. Okay, let's take a look at the bench. Here we have an XL7 connected to a IO Link master. This happens to be the 4-channel version. And the connection between the XL7 and the IO Link master is through a special Y cable that you'll be able to order from Horner. So on the bottom of the Y is an M12 female connector that plugs into the IO Link master. One of the upper legs of the Y is an RJ45 connector that plugs into the MJ/1-2 port on the XL7. And then the other leg, upper leg of the Y that you can't see, is a pair of flying leads where you can connect power, 24-volt DC power, that effectively powers the IO Link master as well as the IO Link devices. Now we have 2 IO Link devices connected here. We have a photo sensor that is measuring distance, and then we have a stack light, which is obviously a sophisticated indicator. So let's take a look at this. Let's start with the photo eye. All right, so see if I can get this so you can see it, see the display. All right, so as you can see, if you can read that display, it has the same reading that we have on the OCS screen. And as I move my hand to different distances, you can see it responding rather well, rather quickly. Okay, so nice response time. So that is our photo eye connection here. Next, let's take a look at our stack light. All right, and we have a variety of different ways we can control the stack light. We have a steady color here, and we can always change that to different colors. We can change to a flash. We can change to multicolor flash with 2 different colors. We can do a 50-50, which we can't see very well based on how I have it connected to the table. We've got a 50-50 rotate, a chase effect, intensity sweep, scroll. So obviously this is a very sophisticated light, and we're controlling it strictly through IO Link. So the only connection between the XL7 and the stack light is through IO Link. So everything is done electronically over that connection. Okay, so that's the first look at IO Link connected to a Horner OCS. In this case, we've demonstrated a sensor input and a fairly sophisticated indicator output. So that's something to remember, and that is that we often think of IO Link for sensors, but it works just as well for actuators as well. So inputs as well as outputs. Okay, let's talk about the rollout of these products. The initial IO Link products have been added to the Horner website and price list. So your distributors do have all the information in terms of part numbers and pricing and those sorts of things. On our Horner website, there is an IO Link product page now that you can access that has all kinds of information on it. Some of the accessories I've talked about, like that interface cable, that Y interface cable between an OCS and the master, those will be added in the upcoming weeks. They're not quite up there yet. We're planning several YouTube live stream sessions for this summer on how to integrating IO Link with OCS. We've actually got one slated for later on this month. So there's lots going on with the rollout. From a supporting material standpoint, again, I've mentioned the fact our product pages are up and running now. We've got cut sheets and users manuals along with links to the configuration software. You will be able to receive, it's not there yet, but you will be able to get sample code that you can use as either a starting point or a routine that you can copy and paste into your particular program if you choose. If you're using register-based ladder, which a lot of you are still, and we certainly have not obsoleted it or anything and don't have any plans for it, obsoleting it. But if you're using traditional register-based ladder, we'll have routines that you can drop into your project where they'll be pre-mapped to specific register banks and those sorts of things that you'll be able to take advantage of. For those of you using the variable-based languages like IEC and our variable-based advanced ladder, we'll have some user-defined function blocks for you folks that you'll be able to drop in as well. And I just mentioned a couple minutes ago, we've got plenty of videos planned for this summer, including one later this month. So that is what I wanted to present to you today. If you do have any questions, now is the time to ask. So we've tried to be thorough and cover a lot in these 30 minutes or so, or 20 minutes or so, but don't hesitate to ask questions. So I'm going to bring in Casey Gardner now as our product manager, and Casey will be answering the questions. So here's the first question we have from Kyle. What is the maximum number of IO Link devices you can connect to the controller?
Sure. So for these, they will come in either 2-channel or 4-channel masters. So that would be either 2 IO Link devices or 4 IO Link devices, depending on which master you purchase.
Right. And certainly I could see scenarios, and I'm sure at some point we'll be covering those on our live stream channel. I can see scenarios where you could use multiple masters. That certainly is doable.
Absolutely.
Yeah. So it really just comes down to how many devices you need to communicate with, that sort of thing. The other thing is when we offer that hub, if you're talking about traditional sensors, you can start adding a lot of those to the system as well, right, Casey?
Yep, absolutely.
Okay, very good. Okay, next question from Frederick. What is the default Modbus RTU baud rate?
I do not know off the top of my head.
Well, since I have been playing with it and putting it together, I think I know the answer there. It's either 19200 or 38400. I'm pretty sure it's 19200 as the default. I think you can go all the way up to 576 as far as a configuration option, but I'm pretty sure the default is 19200.
Yeah, that sounds right.
Okay, next question from Daniel. Is polling set up through the hardware config or through a user-defined function block or some other logic?
Sure. So it would definitely be set up at the protocol configuration, actually. So you can do some of the mapping through the UDFB if needed, but in terms of One of our advantages for protocol communications is really mostly through configuration rather than ladder commands or anything. So it would really be through a protocol configuration on our side.
Yeah, and I think some of the extra code that we'll be providing will help with interpreting IO Link data from specific sensors. If you took a look at that stack light, man, that's a sophisticated piece of equipment. There's a lot of data to exchange with that sort of device if you really want to take advantage of all of its capabilities. So we'll be providing some extra code that you wouldn't absolutely need in order to make the stack light work, but which would help you apply it in a more sophisticated fashion. But you certainly wouldn't need it just to get it rolling, that's for sure. While we wait on some more questions, so we're not holding up questions at this stage. Continue to type them in if you have them. I want to cover a couple more things with you. We're at the start of trade show season. So if any of you are in the Midwest, specifically can be in the Detroit area later this month, we're going to be at booth 2044 at Automate between May 22nd and 25th. We're going to have not only kind of products that you're already familiar with in a lot of cases, we're also going to be previewing some pretty cool stuff that will be the first time it's shown anywhere outside of our, R&D center. So if you have an opportunity to go to Automate this year, if you're in the Midwest and you can make the drive for that day, I would highly encourage it. We would really love to see you there. So we got a couple more questions. Let's go ahead and attack those. So where do you get the registers that are available to pull? From the manufacturer itself?
Yes. So each IO Link device basically has, I forget the name of it off the top of my head, but basically
an IODD sheet.
Yeah. So it's basically its own defined parameters for that matter. So that's where basically all that information is going to be mapped.
Exactly. So you'll take a look at the IODD sheet in terms of, where the data is mapped for the device. And then the data comes into a specific location in the Horner memory based on the example code we send you or based on the way you've set up the polling in the hardware configuration. And then effectively, you'll just look for the specific data you're interested in that bank of data, depending on whether it's connected up to IO Link device 1, device 2, device 3, device 4, etc. So next question, this is for Kyle. You mentioned that the master can retain the sensor setup info and can reprogram a new device. What happens if the master needs to be replaced? Good question. I think you want to tackle that one, Casey, or you want me to grab that one?
Sure. We can basically tackle it together. So my understanding is that the sensor would still retain its information, but setting up a new master, you would be able to then pull that configuration data into the master using the software. Is that correct in your experience?
That sounds right. Yeah, that sounds right. Now you probably also, I'm guessing there's probably a way also, and I haven't played extensively with the Banner software yet. I've worked with it, but not as extensively as I will be here shortly. I'm pretty sure you can probably also save configuration away using the software as well, but that's something I'm gonna have to verify. Next question. If we use the IO Link, that means we don't need smart IO, and can we connect with built-in IO PLC? Let me see if I can interpret that a little bit. I think what he's saying is that the IO Link seems to be an alternative to traditional IO or traditional expansion IO. And I think what I would say to that before I open it up to Casey is that's true. Absolutely. You might choose that you want all of your IO to go through IO Link on a given piece of equipment. That's very possible. But it's also potentially very practical to do a little bit of mixing and matching. For instance, you might have a few very sophisticated sensors that you want to connect over IO Link, but you might have a bunch of traditional push buttons and other type actuators that a traditional IO connection may be perfectly appropriate. And another scenario to think about is sometimes the IO on the door, maybe selector switches and indicators, pilot lights and push buttons, those sorts of things. Sometimes those are ideal to wire directly to the back of the OCS that's also mounted on the door. So you probably wouldn't want to use IO Link for that. I mean, you could, but you probably would want to take advantage of the built-in IO for that scenario. So I can see a lot of situations where you would mix and match between IO Link type IO and traditional IO. Does that seem reasonable, Casey?
Yeah, absolutely.
Okay, very good. I might have missed it. Are you only compatible with IO Link masters over Modbus RTU? For instance, a Turk IO master Modbus over Ethernet.
No, definitely not restricting it to RTU specifically. We're definitely compatible with Modbus over Ethernet as well for numerous different applications. For the products we're offering and partnering with Banner on, we're focused on cost effective first and foremost. So that was an example where we found them very advantageous for that, as well as we have an RS-45 port on basically every OCS we've made for the last number of years. So that was a big thing as well, is to have a compatibility with all of our products as well. And again, we have Ethernet on probably 99% of them that would still be compatible with any other Ethernet masters at this time as well.
Sure. So there's absolutely nothing preventing you from applying a third party, even a Banner for that matter, Ethernet-based IO Link master. You just wouldn't source it directly from Horner. And some of the example code we'll be providing wouldn't necessarily directly apply to it. But, again, there's, as Casey mentioned, there's no reason why you could not apply that if you would prefer that. Let's see. So another question here is, if it's not possible to show, could you please talk a little bit about the configuration? What we're going to do with the configuration side of things is we're going to have a whole lot of, we won't be covering it in this webinar, but we're going to be having a whole lot of our Tuesday live streams this summer, especially, that will cover IO Link configuration using the software, using the example code that we provide, all kinds of different examples. So keep tuned for that over the summer as we get all that material prepared, and it will pretty quickly build up a library of technical information in the video form. And of course, we're not avoiding things like white papers and hard documents, but we found that people do tend to like to see demonstrations. Okay, another question from Daniel. So if I understand correctly, IO Link's underlying comms with the PLC is based on Modbus.
For our, again, basically the IO Link is point to point. So it's going to be IO Link sensor to IO Link master. And then our comms from the PLC or OCS side of things would be Modbus to the master. Exactly.
So that's effectively how that works. Okay, so a couple more things we want to cover real quick before we let you go. And if you have a question, you still got a couple minutes to get it in. We're here every Tuesday at 2:00 for our normal Tuesday live streams, where we cover a variety of different technical topics. And if you can't join us Tuesdays at 2:00 live, we've got lots of videos on the website and on our YouTube channel that may cover the specific topic that you need for your next OCS project. So don't hesitate to use our video search tool on our website, or to peruse our YouTube channel to see if we've already integrated that sensor or that application that you're thinking about doing sometime with OCS coming up soon. Now, for our Tuesday live stream coming up this upcoming Tuesday, so 6 days from today, that particular topic that we're going to be covering is using an Ethernet barcode reader with Horner OCS. So we've got a Ethernet barcode reader from Data Logic, and they have been kind enough to agree to join us to talk about it, and we're going to be demonstrating it. So it's an example of some of the kind of product integration type live streams that we will do from time to time to kind of help you see how, maybe you can very effectively utilize a variety of different automation equipment with the Horner OCS. Okay, I think that is it on our questions. Lots of great questions, guys. We really appreciate you joining us. Keep tuned to our live stream channel for more videos on IO Link. And again, check out our website for the IO Link page. Thanks again for joining us.